Welcome to another explainer. Today, we are completely shattering absolutely everything you thought you knew about speed. Seriously, I want you to imagine pressing the accelerator and in less than 2 seconds, traveling faster than most cars on the road can even dream of. Today, we're dissecting the fastest accelerating cars ever built, the 2026 edition of an absolutely incredible engineering arms race. So, buckle up. Just look at that number, 1.4 seconds. I really want you to try and visualize the sheer visceral violence of a launch like that. That's the time it takes to go from a dead standstill stop to 60 miles per hour. That's about 97 kilometers per hour. To put that into perspective for you, before your brain has even properly processed the physical sensation of the launch, literally before you can fully register those G-forces pinning you back into your seat, the car is already approaching 100 kilometers per hour. It's a level of acceleration that honestly just defies common sense. But, this brings us to a massive misconception in the automotive world. When someone asks, what's the fastest car, our brains automatically jump to top speed. But here's the surprising truth. The car with the absolute highest top speed isn't necessarily the machine that launches the hardest off the line. Actually, achieving a record-breaking launch requires a completely different engineering philosophy than chasing a record-breaking top speed. Okay, let's dive into this. Meet one of the most unbelievable machines responsible for that 1.4-second launch, the McMurtry Spurling. But there's a catch here. It isn't a normal road car. It's a tiny, highly specialized electric track phenomenon. It has been designed specifically around extreme lightweight construction and revolutionary aerodynamic performance. When your single obsessive goal is pure acceleration, you end up with a hyper-focused machine like this, which proves exactly how far engineering can go when all the compromises for the street are completely thrown out the window. But what happens when you actually need to keep those street-legal compromises? Well, that brings us to road-legal hypercars like the Rimac Nevera R and the Aspark Owl. These things are extreme electric vehicles, pushing out more than 2,000 horsepower through 4 independent electric motors. Both of them claim a 0 to 60 time of around 1.7 seconds. The Owl features this extremely low aerodynamic design. It literally looks like a futuristic racing machine for the road. The Nevera R, on the other hand, essentially operates as a computer-controlled four-wheel drive rocket with seats. They combine extreme futuristic aerodynamics with just absolute brute force. Comparing these two approaches highlights a pretty brutal engineering reality. On one side, you've got the track phenomenon, like the Sperling. Its hyper-specialized, incredibly lightweight design is what gives it that crazy edge to hit 1.4 seconds. On the other side, we have the road hypercars like the Rimac and Aspark. Sure, they carry more weight because of safety and road legal requirements, but they compensate with ultra-powerful engineering and thousands of horsepower to rip a 1.7-second launch. Both approaches are absolute masterclasses in physics. Now, right at a time when so many performance cars are going fully electric to chase these numbers, Bugatti has chosen a completely different path. Meet the Bugatti Tourbillon. This is the combustion engine's counterattack. This luxury hypercar uniquely combines a massive, naturally aspirated V16 engine with a hybrid electric system. Together, they pump out a claimed 1,800 horsepower, allowing the Tourbillon to reach 60 miles per hour in under 2 seconds. What's so astonishing here is that this isn't some stripped-down racing machine. It's built to combine world-class craftsmanship and comfort with mind-bending performance. And this brilliantly illustrates the current landscape of extreme performance. Up at the top, the PureTrack EV sits at 1.4 seconds. Right behind it, those heavy-hitting road EVs at 1.7 seconds. And right on their heels, the incredible engineering of a V16 hybrid coming in at under 2 seconds. Seeing them compared like this really begs the question, what is the underlying science that makes the electric powertrains so dominant right off the starting line? It's a fascinating question, isn't it? Why exactly are electric cars dominating these acceleration records so convincingly? Well, to understand this, we have to pivot away from the specific cars for a minute and look at the physics, the core engineering that actually makes these sub-2-second launches a reality. Fundamentally, it all comes down to how power is delivered to the ground. So the crucial point is the mechanics. You see, a conventional combustion engine inherently has a delay. It has to build up engine speed, or revs, and then it has to route all that power through a multi-speed gearbox. An electric motor? It completely bypasses that whole process. It delivers enormous amounts of power and instant torque almost immediately to the wheels. When you pair that instant direct power with multiple motors and sophisticated all-wheel drive traction control, the car can distribute the exact right amount of power to each individual wheel in actual milliseconds. However, as literally any engineer will tell you, getting a 2,000 horsepower car moving quickly is really only half the battle. Keeping a machine like that stable, safe, and actually planted on the ground requires a vital supporting cast of components. I like to call these the hidden heroes of acceleration. Without the advanced aerodynamics pushing the car down, the specialized tires gripping the asphalt, the custom suspension keeping it level, and the millions of lines of code in the power management software controlling the slip, well, all that instant torque would just result in spinning wheels and a whole lot of smoke. Which leads us to a necessary redefinition of speed. Consider this a bit of a light bulb moment. Acceleration is strictly a measure of how quickly a vehicle reaches a certain speed. Top speed, on the other hand, measures the absolute maximum velocity the vehicle can achieve over a long distance. So the McMurtry Spiraling is famous for its launch, but it's not designed to be the ultimate top speed chaser. They're two entirely different physical challenges. Let's move to our next contender and see how this builds. If the Spiraling is the undisputed king of the launch, who's the new king of the long straightaway? Enter the Yangwang U9 Extreme. This Chinese hypercar has completely shifted our paradigm of what electric top-speed capability looks like. It's proving, once and for all, that electric cars aren't just one-trick ponies made for short little sprints. Just let that number sink in for a second. 496.22 kilometers per hour. Wow. In September 2025, over at the ATP Papenburg track in Germany, the Yangwang U9 Extreme achieved this verified speed. That made it the world's fastest production car by verified top speed at the time of the record. That is a staggering achievement, and it requires an entirely different masterclass in engineering compared to the quick launches of the hypercars we talked about earlier. Now, what's really interesting about this slide is how it reveals the monumental, specialized engineering required underneath all that dramatic bodywork just to handle those extreme velocities. To push a car to nearly 500 kilometers per hour, the U9 Extreme relies on a high-voltage electrical system feeding 4 motors that spin at incredibly high speeds, producing roughly 3,000 horsepower. And again, power alone just isn't enough. At almost 500 kilometers an hour, the air literally feels like a solid wall. It requires completely bespoke, advanced suspension technology and specialized tires just to keep the car from disintegrating or taking flight. And you want to know the most exciting parts? There is no way they're stopping there. BYD, the manufacturer behind the U9 Extreme, has already announced plans to push the boundaries even further. In 2026, they are explicitly targeting the historic 500 kilometers per hour barrier. So that incredible 496 record we literally just looked at, yeah, it might not remain where it is for very long. The envelope is constantly being pushed. Looking at the broader horizon, it's pretty clear that this rapid evolution of hypercars is operating on 3 distinct fronts. First, battery technology is continuously improving to discharge power faster and way more efficiently. Second, electric motors are becoming lighter and vastly more powerful. And third, and perhaps most importantly, we're seeing unprecedented software precision. Mastering the control of thousands of horsepower through exact millisecond by millisecond software adjustments means we're really only just getting started here. So we've covered a lot of ground today. We've seen the track-focused 1.4-second launch of the Spiraling, those 1.7-second electric rockets from Rimac and Auspark, the absolutely gorgeous V16 hybrid Bugatti, and the 496-kilometer-per-hour top-speed dominance of the Yangwang U9 Extreme. Each one of them represents the absolute pinnacle of their specific engineering goals. So I want to leave you with a provocative question. If you had the keys to just one of these machines, would you choose the face-melting instant torque of the ultimate launch or the sustained, terrifying velocity of an absolute top speed run? Think about it, because the definition of speed has literally never been more exciting. Thank you so much for joining me for this explainer, and keep learning.